Hello viewers, welcome to Bhadra Academy, and in this we are going to discuss about the CUET undergraduate program, where we are going to talk about the subject paper physics, and in this video we are going to talk about the chapter electrostatics, in which again the subtopic Gauss theorem we are going to discuss in this. Also, for the CUET undergraduate program that Bhadra Academy has brought up for you, this is our contact details. You can see in the screen, and you can call us for further details about the course and other curriculums and the test series also. Right? So about the course, about the fees and other structures, you can definitely get your queries right by contacting on this number itself. So do hurry and contact us for further details. So let us begin with our video, our topic, that is Gauss theorem. But before that, we need to have some insights of few other concepts also. So to begin with, we'll start with the electric field. So what is an electric field if we talk about? So in electric field, first of all, we must see that there are two kinds of charges, that is positive and negative charges. So there are two kinds of polarity of charges, that is positive, in which you can see the positive charges emits the electric field lines and the negative charges attracts the negative electric field lines. Okay. Secondly, we can see that if there are opposite polarity charges, so they will have a force of attraction. If they are same polarity charges, they will have a force of repulsion. Okay. So, and therefore from this we can say that electric field basically produced by a charge Q, capital Q, is given by this equation, that is E, that is electric field at a point charge at a certain distance, that is R, and that will be the magnitude of the charge divided by the square of the distance plus the constant, means multiplied the constant 4 pi epsilon naught. 1 by 4 pi epsilon naught is the constant with a unit vector, because we need to give the direction of on which the electric field is required. So therefore the equation is this. Parallelly, if we talk about the force exerted by the charge at that point itself, so this also can be given by the point test charge that we have brought with the main charge that is there, the distance r square, and the constant 1 by 4 pi epsilon naught. So this is the equation that is giving us the force exerted by the charge capital Q. From the above two equations we can solve this, and from here we can separate this part, right, and this part we have seen that it is electric field, and therefore we can denote it as force equal to electric field multiplied by the test charge at a distance r, which is given by the direction unit vector r. Or else if we see the magnitude, that is the force exerted by any point charge capital Q at a test point Q, is given by the electric field at that very point and the product of the test charge that is brought up to that point. Okay, so therefore this is the whole formula and the concept of electric field that is required for this. Further, if we see, I hope that is understood to you. So further, if we see, there may be another concept also, and that is a very important concept of electric flux. Without this, the Gauss theorem cannot be understood. What is electric flux? So basically flux is the total electric field lines. Now just we have seen the electric field, and we have seen that the electric field lines are there. So whenever electric field lines pass through a certain amount of surface, right, any amount of surface it may be, right, it may be a plane surface, circular surface, any surface, curved surface. So if we take a test surface, that is this surface, and electric field lines are passing through the surface, and also the surface is inclined at an angle theta. Okay, so now if we talk about it, so what is electric flux? Electric flux is actually the dot product, that is the electric field lines that is passing through the particular area which is A, right, at an angle theta, that is cosine of that angle, that is cos theta. And therefore in words you can see electric flux is defined as the total number of electric field lines passing through the given surface area. Mathematically it can be expressed as the dot product of the electric field intensity vector and the area vector. Okay, so this is again the dot product of the electric field intensity and the area vector, and denoted by the phi, that is EA cos theta. Okay, and theta is the angle between the electric field and the area vector, and it is given by the SI unit Newton meter square per coulomb. Newton meter square per coulomb is the unit of electric flux. So we have seen electric flux, and also we have seen the electric field. Two things are clear for us. Another thing we will see, that is electric dipole. So what is an electric dipole? Again, we have seen there are two poles of charges, that is positive charge, negative charge. So you have plus q charge, minus q charge, that is separated by a distance, that is 2a, is denoted by 2a, and therefore since these are opposite charges, so they will exert a dipole. A movement will be exerted, right? It can be any kind of movement, circular movement, angular movement, or any kind of movement, but a movement will be generated, and this movement will be known as electric dipole. Okay, so basically if we see that electric dipole is a pair of equal and opposite point charges, these both point charges are having equal magnitude, but only the direction is different, plus and minus, separated by a distance 2a, and the magnitude of the dipole is given by p, that is the product of the charges. Since the charges are equal, so we denote it by q, and the separated distance, that is known as 2a, right? So this is the magnitude of the electric dipole that is exerted by the system, this. Okay, now if we see that if this system is like this, right, so here we have plus q and minus q, and we have a point p. So now this is separated by a distance r, which is from the middle of the this. Okay, so now we will see that what is the effect, what is the dipole, right, exerted at point p, that we are going to see. And this is an angle theta, this point p is at angle theta. Okay, so this is the whole situation, and here we can see that at point p, what is the electric potential we are going to see first of all. So here the electric potential, because of two charges, so the total potential here V is denoted by the constant 1 by 4 epsilon plus the dipole movement P and cosine theta of that, and the distance, square of the distance between the point P and the dipole. Okay, so this again can be denoted by the unit vector r and the dipole this. And from here we have two situations. If theta angle is 90 degree, means if this point is totally 90 degree, okay, perpendicular to the dipole, so then what will happen, the potential will become 0, because both the dipole plus q and minus q will be exerting equal and opposite force. So in that case if we see, so that potential will become 0, and if it is 0 degree, means if it comes just aligning with the dipole, then the potential will be this, that is the constant 1 by 4 epsilon naught P by r square. So these are the two situations that will exist during the electric dipole situation. Okay, so I hope that is understood to you, it's clear to you. And now if we come, so what is Gauss theorem? So now Gauss theorem will be crystal clear to you, because we have understood the above concepts, right? So here finally if we talk about, so Gauss theorem or Gauss law is saying about a point charge, right, and which is enclosed in a closed surface. This is a spherical surface, this is a sphere. Okay, so this is a sphere, and in this sphere in between you have a positive charge, and it is exerting equal electric field. Okay, because electric field at a certain point, so this certain point is the surface, and this surface is known as Gaussian surface, where the charge is distributed equally. Okay, so the whole charge which is situated here is distributed equally on the surface. So at any point of the surface you find equal electric field. Okay, so this field we are taking at this point, and a small area that is denoted by the ds. Okay, and Gauss law is stating that the total flux, right, the total flux that is here, that is equal to or proportional to the total charge enclosed by the surface. Okay, and this is denoted by the integral vector of electric field and the surface vector of ds, right, or else you can see the total charge enclosed divided by epsilon naught. So here in words you can see the Gauss theorem, the total charge enclosed is in a closed surface is proportional to the total flux enclosed by the surface, and therefore if phi is the total flux, epsilon naught is the electric constant, total electric charge q enclosed by the surface is given by this. This is the total charge given by epsilon naught and the total electric flux enclosed by the surface. If we bring it here, so then we will have the total electric flux that is directly proportional to the total charge enclosed and by epsilon naught. And finally the Gauss theorem is also stating the same thing, that the net flux through a closed surface is directly proportional to the net charge in the volume enclosed by the closed surface. It may be any closed surface, it is spherical surface, it may be a cylindrical surface, it may be a random surface also, but the total charge enclosed by the surface will be always be given by the integral vector of electric field and the small derivative of the surface, or else you can say the total charge enclosed by the surface divided by the epsilon naught, that is the electric constant. Okay, so this is the Gauss theorem as a very important theorem for the examination point of view of CUET, a very important topic. Also questions will come from this topic, so you must be clear on this very topic, and I hope that in this lecture certain things are definitely clear to you, right? So with this, I thank you all for being with us in this lecture series, and I hope that we have clarified certain things to you regarding the Gauss theorem, the Gauss law, and the topic related to electrostatics. So this is how the physics course will go on, and again you can see the contact number in the screen itself. You can contact us for further queries, whatever doubts you have regarding the examination, the syllabus, the topics, the course, the fees, anything you want to ask, you can clarify in this number, right? So don't wait, you can contact us and begin with your preparation of CUET undergraduate program. Till then, thank you so much.